and then we could just do it, I guess.
All right, we use words.
Hello and welcome to the Hackaday Podcast. I'm Elliot Williams, Editor-in-Chief of Hackaday.
And I'm Tom Nardi, Managing Editor.
This is episode 196. This time we'll be talking about flexing hard PCBs, the dangers of white filament, and the Jetsons kitchen computer that never was. This week, ChatGPT was in the news basically everywhere, and I really wanted to get it to make up a fake introduction to the Hackaday podcast for me and read it out to you, but they insist on having my phone number to sign up for the thing, and I am not giving OpenAI my phone number.
You want me to put my number in? I think they have my number from something else already.
If anyone else, yeah, so if anyone has an OpenAI account that they want to enable me to use, you can send the details to editor@hackaday.com.
But yeah, seriously, in the news, like I was contemplating like blocking it because it seems like everything I see.
Yeah, right?
Now that I've ended up being hooked on Mastodon, I do like the filtering abilities where you can just say, no, I don't want to see that right now.
Block this topic. Yeah, that's the other hot topic is switching up from Twitter to Mastodon, and that's interesting too. It does have a bunch of neat features like easily blocking topics and stuff. Something I've never understood about Twitter actually is that you follow a person but not necessarily a topic. Like, so if you're interested in, like, I'm that guy, I go online to hear a couple things from a couple of my friends, but basically I want the hacks, please. Yeah. And people talk about all sorts of other things other than hacks. Even totally reasonable hackers talk about other things other than hacks from time to time. And I don't necessarily always want to hear it. And I've always hated this, like, follow this person / don't follow this person dichotomy, where rather I'd want to follow this topic and not follow this topic from these people.
Well, I'm glad you said it because I felt the same way, but I thought it would be maybe something was wrong with me socially to say it out loud.
I love you. I just don't want to see pictures of your cat.
Yeah, exactly. It'll one post will be about, them working on some obscure piece of hardware, and then they'll be like, and now, Mr. Sugar Plums has seen his first sunset. I'm like, I don't care. Like, I go back to the old computer. Well, I had a little bit of like podcast inception this week because while getting ready for this podcast, I was listening to another podcast that was about us, or at least, at least not us personally so much as Hackaday, and specifically Hackaday Supercon. It was the episode 6 of the Bootloader, and it's I guess a relatively new podcast. It's a spin-off of, I think they have a Circuit Python podcast, but it was Todd Kurt, which is like a longtime friend of Hackaday, and he was talking about his experience going to Supercon and all the things he liked and the talks, and it was really cool to, an outsider's perspective is probably the wrong word. We like to think we do a good job, right? And people tell us we do a good job, but it's cool to hear someone say we did a good job out of earshot of us. You know what I mean? Like, he could have been like, them guys, I don't know.
Those Hackaday guys.
Yeah, the tacos were the best part, and then I checked out early. But no, I mean, it was a lot of fun hearing somebody else enjoy it as much as we did, and kind of go over like the favorite talks, and of course the badge and all that stuff. So we'll put the link for their show notes in our show notes.
Exactly.
Something like that.
Yeah, shout out to Todd Bott, longtime friend to Hackaday. He and I live secret double lives. We share a number of arcane, obscure synthesizers between us. And like this one time that I was having trouble with the rotary encoders on a Yamaha A4000 sampler, I Googled it on the internet. And who tells you how to fix the rotary encoders? Todd Kurt, ladies and gentlemen.
There you go.
So he's the person to thank for my rotary encoders not skipping anymore. Speaking of skipping rotary encoders, shall we head off to What's That Sound?
There we go. I hope that's not the sound.
That was no segue.
This is a journey into sound.
What's that sound?
What's that sound?
Oh. Wow, okay.
What do you think?
It's vaguely terrifying.
Yeah.
It's funny. What at the very beginning, I thought it was like a old airplane starting up or something. The first thing that comes to mind is like a strand beast or something like that.
Okay.
You know, a lot of articulated little bits
Right? Yeah, there's
pounding its way down the beach.
definitely scarier than that.
It's even scarier than that.
Yeah.
I don't know. I think you might got me on that one.
Awesome. So if you in the audience know what the sound is, head on over to hackaday.com/podcast. Leave us your handle and your best guess. And if you get it right, and we pick you randomly out of the hat next week, we will send you a Hackaday Podcast t-shirt.
And if you're comically wrong, we might read that also.
Well, let's start up the hacks. This week, I'd like to start with an interesting one, mostly because it was a new technique to me. Rihanna Al-Sultan, clever design technique makes flexible PCB fit for a queen. Basically, she's made a flexible PCB crown. But when I say flexible PCB, you're all thinking, oh yeah, that's just that PCB on a substrate of Kapton. But no, this is a trick to take a regular PCB. I think actually at their lab they're using FR1, but might as well be FR4. Rihanna is basically cutting it like you would with kerf bending to bend wood. She's putting all of these like alternating slots in it, and it actually makes almost a 90-degree bend in regular PCB material with the circuit still intact on top of it. And so it's a really cool design and just kind of making use of this idea to make a PCB object, in this case it's a crown, in a shape that you wouldn't have thought possible. And that's what I really liked about this, is that I think this is part of the Fab Academy, and they are milling PCBs anyway. So this isn't even like an extra step for them. It's just cleverer design to make a flexible PCB. And she says she got this trick from another person, Quentin Bolsey, also at the Fab Academy. And I'll link his project in here too, because it's really cool. It's a flexible capacitive 3-dimensional sensor. So you can kind of put your finger in space and it'll map it out for you. And it uses this ability to kerf bend and fold the PCB to make the 3 different right angle capacitive sensor plates feasible on one printed circuit board. I thought that was really cool too. The last thing that was new to me here was the software that Rihanna is using called SVG PCB. And this enables her to basically programmatically do all of the circuit board layout, including those crazy cutouts to do the kerf bending. And it's kind of like both Tom and I do 3D modeling with OpenSCAD a lot. It's kind of like that, but for making PCBs. It's code to make PCB traces and borders and outlines. And if you have a totally crazy outline shape, like this like slit kerf bending thing, that's exactly the sort of thing you'd want to do programmatically and not have to put them all in there by yourself. I think it's really cool that the one piece of software does the trace routing and the outline cutting, but I'm more familiar with a bunch of CNC router tools. I think myself, I would do those two things in different steps, like design the PCB in like KiCad or whatever normal, and then do the routing with normal CAM software. But it's really cool here that she manages to do it all in one piece and just like software, hand this off to the milling machine, and then bam, out it comes.
You might have gotten me in trouble with the software here because you're right. It is very OpenSCAD. Like I'm kind of playing with it while you've been talking. It is very. I don't know. It's interesting. It's for 3D models, I love doing this, but maybe this is a bridge too far for me. Doing each little trace, but I mean it is very very powerful stuff. It is really very cool. It's web based too, which is pretty cool. Everything's in the web these days.
If you're used to doing like SVG graphics layout, if you're doing graphics stuff, you have to draw every line. This is just that.
Yeah, right. And then you skip the whole schematic step. And I guess for some relatively simple stuff where you don't need a schematic and you're just kind of going from mind to PCB. But yeah, I mean, it's a really cool project. I did think, I'll admit, I thought it was bigger at first. I didn't realize the little top of the crown is a USB port, which would make this crown like for a doll, I guess. But hey, it's still cool. There's limits, right? I thought it was interesting that they're essentially huge traces too, right? Like where all the cutout is, and it made me wonder if there's some kind of first glance, you think of some kind of antenna.
Ooh, right.
And I do wonder if there's maybe some kind of something there, like conformal antennas that you could kind of create with this technology, which would be interesting. I thought at first it was actually like what do they call it, a rectenna. It's a microwave thing for like you can light up LEDs just with a bunch of wires and it gets hit with Wi-Fi or whatever. Yeah. So it kind of reminded me of that at first glance.
I don't know. I like it for the mechanical PCB nature of it. I can imagine you would not be able to get a manufacturer to do this for you.
Yeah, right.
like they would probably look at the milling path and be like, no, sorry, we're not doing that at all. But
I'd love to see somebody send this. Send this off for fab, and I want to see what they say.
But that made me think of a number of other times where people have abused the fab houses. And and for instance, Voya Antonich back in 2015, my God, time flies, wrote an awesome piece for us, How to Build Beautiful Enclosures from FR4, aka PCBs. And that is just a great tutorial on his kind of lifelong process of making enclosures, out of the PCB themselves. And it's just a great way to use the fact that the board houses can do precision milling for you. And then also, I say it every time I think about this, Nick Poole's talk, boggling the board house from the last Supercon was just so good. And this is the sort of stuff that he would try to pull off and try to get someone to manufacture it for him. And they'd come back and be like, no. He does some really cool things with like cutouts there that cover up tack switches and stuff. You really need to go watch that talk.
I was actually going to say, didn't somebody give a talk that's literally abusing the board house? But no, it's boggling the board house, which is, I guess, a little nicer than abusing the board house.
Between these two, if you watch those and then take this kerf bending idea from Rehana, I think you've got the ultimate PCB fold up, assemble it yourself container. And I want to see someone make one.
The gauntlet has been...
That's right.
All right.
Someone will do it. Someone will do it.
Well, this next one just came out. It's from Al Williams, and it says, PSA, watch out for white filament. It's an aggressive warning, maybe. Yeah, right? Very, very ominous. The idea here is that Slant 3D, which is a company that they have a print farm, and they print a bunch of stuff on demand, and they do designing and stuff. They've come up with a video, which is equally ominous, saying that white filament will destroy your 3D printer, which is, okay. I mean, it'll destroy your $3 nozzle, maybe. Yeah. But what they're saying here is that the experience they've had doing this farm and what they've been seeing is that the white filament is much more abrasive than other colors. And again, we're just talking about basic white like PLA, not white with marble chips or something in it. It's literally just white. They've done some research, and according to them, the issue is that the colorant added to make it white, titanium dioxide, it has a very large grain size compared to what goes into the black filament or blue filament or whatever. You gotta remember, when the filament comes out, originally it's all the same milky kind of, I think they call it natural or whatever if you buy a roll of it. It's just and then they have to add colors to it. And this larger grain size, in theory, is eating up the nozzle in the same way that like a brass fill or a wood fill filament might do. And, there's some, as you can imagine, debate in the comments. And some people are saying, who cares? Nozzles are cheap. And honestly, they are pretty cheap, and it's not a huge deal. But it made me think, I've always, personally, I've always had pretty poor results with white filament. Like, when I print something out, it wouldn't look good in white. It would look kind of rough, and I actually avoid white. I mean, I have a lot of rolls of filament right next to me in my storage thing, and I don't even think I have a roll of white because I've never been, I mean, it's regardless of who's making it, like the brand or whatever, I've never been happy with white. It just doesn't look good. And I kind of wonder now if that's somehow related, is is the finished product have, a weirder texture because of these color grains in it, or is it just, my imagination that happens to agree with an article I read on Hackaday?
I have no idea. I mean, I do agree with you that A, nozzles are cheap, and B, you should get like a 10-pack of nozzles anyway.
Yeah, if you're holding on to one nozzle, you might have made a mistake. Just go back and buy another one.
In fact, go get yourself an assortment of nozzles so you
Yeah.
can play around with different nozzle sizes and stuff too. Like $6 on eBay will get you a set of 6, one of every size, and you can just play around to your heart's content. Plus, when you wear one out, you can replace it. But yeah, nozzles are consumable, so that doesn't bother me. And they're the cheapest consumable, I think, in all of 3D printing. So it doesn't even bother me in the least. But at the same time, I share your experience too. Of the hardest filaments I've ever printed was some white. And I've only gone through 2 spools of white in my whole life. And one of them was definitely cheap. And the other was from a pretty reliable, not like my top shelf supplier, but a little middle of the road filament supplier. And it was pretty crappy too. I mean, so I hear you. I wonder if it is the titanium dioxide.
I mean, I'd like to blame that, and then I can say it's nothing I did wrong. It was that damn titanium dioxide. Once again, hounds me.
But it's true, the different colorants going into 3D printer filament definitely seem to affect the performance. Like, I can get 3 different rolls of filament from the same producer in 3 different colors, and they will want different printing temperatures. What's that about?
Yeah. And, there's somebody in the comments that says, they process 50 tons of pigment a year. Because, of course, the Hackaday comments, of course, there'd be a
Yikes.
a pigment processor in the comment. This person says that 200 microns, which I don't know that we qualify to, 200 microns is supposedly the size of this white pigment. They say that's insane, and they've never heard of anything that big. And if it is, it's got to be the cheapest pigment, and they want to see it because they've never seen it bigger than 80. So, I don't know. I don't have a sample of this 200 micron pigment here, but it is interesting. I do wonder where their original info came from. I didn't see, they have impressive looking images, like it looks like. But you're right. I mean, it definitely, the stuff that goes into it, it all changes it. It's such a fine balance in the first place. I mean, you could have the same rolls from the same company, same color, and then, this one's a little bit newer, so it doesn't print as well. It's just one of those things of 3D printing. But I will continue to not use white filament. And if anybody asks me, I will say that I think it's because the titanium dioxide is ruining my prints. So I just print everything in black or the occasional Hackaday orange.
Exactly.
Incidentally, Hatchbox orange is very close to.
Oh, really?
Like a nice contrast thing. Actually, it's like closer to like the supply frame orange, but that's fine too.
Yeah.
Either way.
Yeah, we should get some. We need to get some filament producer to make a Hackaday yellow filament. My next article is radial vector reducer rotates at relatively relaxed velocity. This is an interesting kind of gear reduction mechanism for like robot wheels or whatever by Michael Rechten. He's calling it an RV reducer. It's basically a planetary gear shoved on the front of a cycloidal gear. And cycloidal gears are the really weird ones. They have these kind of, what is it even? It's almost like a gear wheel, except it's rotated around. It has semicircular cutouts. It's like scalloped all around the outside. And these scallops fit inside poles. There's more poles than scallops, and it's rotated with a cam. And so it like kind of inches around from one gap to the next as it goes around. And that's what makes the gear reduction impossible to explain. And so he ends up getting this kind of wobbly gear mechanism that gives him 35-to-1 gear reduction. It is entirely 3D printed, except it also kind of leans heavily on quality metal bearings because you've got a lot of parts that have to rotate. He takes the thing out, he tests it in his backyard, he leaves it running for a couple weeks under what look like horrible weather conditions, and it comes back with essentially no wear on it, which makes you think it's a pretty good gear drive mechanism. It looks like just the sort of thing you'd want to drive robot wheels with like a stepper motor, or even better, I would say, a brushless DC motor. If you could put a fairly torquey brushless DC motor upstream of this, I think it would be a super way to drive robot wheels.
I like that you said you couldn't explain how it works, because the link at the bottom of the article goes to an article written by one Elliot Williams that explains how cyclical drives work. And that was in December of 2021. So last year you knew how they worked.
I know how it works. I'm just like, how am I going to explain to you?
But no, that other article from last year is probably the primer you should read
that's
before
a good
going
one
into
too.
This one, because it does kind of shows open, and it shows, like you're saying, all the bearings and stuff in there. It's a really cool design. What was the point of running it for a long term outside, though? Is that just like the ultimate torture test? Was there
just to kind of stress test
she's going to do something outside?
No, I think he just wanted to stress test it, so he printed
how do I do that? I'll
3D print a big tractor tire and run it around.
You get like the pictures, it's like out there in the snow and trundling around. I thought at first it was some kind of I don't know, like an auger for moving small amounts of snow, which
right?
Hey, it's Hackaday, like why not? Maybe somebody's got to move a little bit of snow constantly for whatever reason. I don't question it anymore. Preaching to the choir, you obviously have great respect for 3D printed parts, but I love products like this because it does show the kind of, like, how would you do this otherwise? Like without a 3D printer to make these parts. So it is really cool to see these practical things made out of printed parts and torture tested outside. I mean, it's not just like a desk toy. Like, this thing could really do some work. So very cool design. And I love that we still, like, there's still a frontier left, right? Like, we're still seeing these new things get produced. It's not like we're getting tired of them. Like, we keep seeing these like printed gearboxes, but I mean, they all bring something new to the table. It's not just the same old, different gear designs and that sort of thing. So it's a really cool project, and just like how it utilizes the tools available.
Yeah, and he's got the CAD files up, a Google Drive, where he's got the CAD files for you, so you can download it. Sorry, man. I don't. No, he's also got a Thingiverse model for it, if that makes you happier.
Okay, well,
Wah, wah.
yeah, well, I'll do two wah-wahs.
Yeah, totally.
On the hierarchy of wah-wahs, Thingiverse is still beats out Google Drive, but not by much.
But the point is, you can print this out yourself now.
Yes.
And his first iteration of it, he actually prints it out with an SLA printer, and to get the fine detail on the gears, and then discovers that it's not at all necessary, and does it with PLA, and it works just fine. And the stress tested one ends up being the PLA version, and it doesn't seem any worse for wear. So I think this is just a great new gearbox. If you're looking to print a crazy gearbox, this is probably the one you want to look at. If I had a month, I would print all the crazy gearboxes.
Well, speaking of eccentric 3D printed contraptions, this next one up is a prank keyboard, because that's where we're at now, that replaces the numpad with a rotary dial. And it was created for April Fools, so we're either late or early with this one. And it was a prank placed in front of a retrophone obsessed coworker. I don't know. I think I'm ready for it. I mean, I think it's one of those things that started as a prank, and they were like, "Well, no, I'll keep this. I don't want the old numpad," because obviously there's some people who put a lot of miles on their numpad, but I use it just enough that I want it to be there.
Yeah.
So like I could probably get away with it being a rotary dial. But and it'll be worth it for the numbers, just for the laughs. Just for the laughs, yeah. It started with like an off-the-shelf kind of keyboard and hacked into it. Did also replace the numbers themselves with a giant like bar. Is it not even a button? Would it like I was looking at it? Is it just like a non-functional? It's just so you couldn't. Unless you had to use,
so you can't press the numbers.
But you do really need to look into this one. Check the full write up, because it is pretty impressive how they managed to cut into the keyboard's PCB.
Yeah.
To take this rotary module and it just still all works in the end. I mean, I guess a keyboard matrix is pretty simple, right? You just, especially if you're not using those keys anymore anyway, there's no real risk of cutting through all the traces. But like they literally just routed out the shape of this module, stuck it in there, and a little glue to make it talk to the keyboard, including some OpenSCAD for the body. This is really like this is firing all cylinders. This is all the. Okay. And the big thing that covers the numbers is the rotary dial is mightier than the number keys. Is a big one big key that says that, complete with RGB LEDs behind it. All right, yeah, I'm down with it.
This is a proper hack. I mean, there's some hardcore dremeling going on just to fit the rotary keypad through there. And then he's like, oh, how am I going to get this and the keyboard onto the same USB? He's like, screw it, I'll just wedge a USB hub in there. So it's got a microcontroller doing USB from the dialer or whatever. But then he's like, having two cables coming out the back is just dumb. So let's just put
unacceptable.
Put a USB hub in the thing and USB them all together. No, my favorite detail is that it's got all of the punctuation that normally goes with the numbers, like the pound sign and the exclamation point and all that on there too. And I can just imagine holding down shift and then dialing 3 on this rotary thing to get a hash mark. I think that's so funny.
Yeah, right, because even the dial is printed too, which is cool. It talks about using like SVG export to do that.
Open parentheses and close parentheses. Dialing shift 9 and shift 0 on this thing would drive me crazy.
I like, I'm looking towards the end of the write-up. The rotary module is so big, it's actually blown through the back of the case of the keyboard, too. So it's not just through the PCB. It had to go through the whole thing. So, like, even when you flip it over, you see this thing.
That's right.
And there's a little reaction section at the end of the write-up. I want to see all hacks have a reaction section. And one of them says, it makes me absolutely sick that anybody has enough time on his hands to make something like this. And if that isn't a perfect summation of what we're looking for, I might have to get that on a shirt for Supercon or something.
Exactly. Well, not all is fun and games on Hackaday. Here comes a video from Grady of Practical Engineering. And if you've been following his video series, he is a serious civil engineer doing serious life and death civil engineering. And the topic of this video is restarting the power grid when the grid is off the grid. And it's a great explanation of this topic. I remember last year about this time, there was the power outage in Texas, and he did some coverage of that. And really, really great work on that. And this is kind of the last video in this series about how the power grid works. And it's how to reboot it when it goes down. And the point here is that our power generation is generated by generators. And these are, a generator is a lot like a permanent magnet DC motor, except in place of the permanent magnets, it's got more electromagnets. And that means that to make it generate electricity, it has to have some current going through the coils to make them serve as magnets in the first place. And he says they consume about 5% of their produced power run back into the coils to make them serve as magnets. You do this because you want variable strength magnets there, so you can control the amount of power they're putting out, because they have to run at a constant speed because, well, the power grid has to run at a constant frequency. So really neat detail there. But then imagine they go down. You have this power generator that needs power to generate power. How do you bootstrap it back up? The so-called black start power plants that are set up to be able to kickstart the other power plants, the kind of main use power plants. And the detail I hadn't thought about here is that, of course, you need to get the electricity from the black start plant to the regular power plant. And of course, you've got all these power lines kicking around everywhere. But you can't just use the normal paths on these because you'll end up powering the city with your black start power plant. So you need to shut the whole city off first, and then use this as a so-called cranking path to go from the black start bootstrap plant to the regular plant. And once you get that back up, you can use that to then fire up other power plants around it and get these kind of islands going. And then you've got a whole bunch of power plants online and you're ready to switch the city in. but you have to make sure all the power plants are synchronized with each other. So he goes into that because, generators are motors and motors are generators, and you don't want one power plant to be driving the other one. You want them to be in line and all rowing at the same time, right? So the synchronization he gets into, and then the last thing is, of course, he gets into how you have to slowly bring up the load. And so you can't just reconnect the whole city at once, because it's like when everybody flushes their toilet at once. It's a huge drain on the city. And so if you imagine all these fridges that have been out for the last hour and they all really want to turn their compressors on, and then you turn all the power on, it's like huge surge current. And so he goes into that too. Anyway, it's just really neat because it's full of all of these engineering details that go into kind of fortunately, it's not an everyday experience here. I guess the power grid is a matter of everyday experience, but rebooting it isn't. And this is kind of, the extreme engineering behind making it work right.
It's incredible. Like, we just flick the light and we flick the switch and the light comes on. We just take it for granted. Like, there's just magic on the other side of this. We don't have to worry about it. Really cool video. It actually reminded me, maybe not the intent when you're watching this, but it reminded me of Chernobyl, because I'm a big Chernobyl nerd among other nerd things.
Right.
And like, that was what they were actually testing that night, was they had ramped the reactor down real low to see how long the turbines could spin on momentum and produce enough power to run all the stuff at the power plant. So they wanted to see, like, okay, if we lose the reactor or we got to take the reactor offline, how long do we have before we go dark? Because then once you go dark, then it's a whole other thing, So that was like the whole test. And then they're like, okay, that worked. Turn the reactor back on, and it went boom. But but yeah, like, so this is a big deal. Like, you do need to know, like, how long do you have? Because and the last thing you want to do is everything to go dark and cold, because then it's a much bigger problem.
Anyway, just a really cool video about something you certainly, probably, fortunately, don't need to know about.
So, in the closest thing to a proper segue I could come up with for these topics this week, we go from the response to the disaster to what might have caused the disaster. And this is a write-up from Al Williams called "In My Neighborhood, We Played Asteroids with Real Asteroids." And the idea here is this is a web-based, I don't call it a game, but a simulator where you can, like, drop a little marker on the map and you can say how big an asteroid, what it's made out of, and how fast it's going, and you can virtually cause the next ice age. It starts off with like a little red circle around Manhattan or whatever, and it's like, oh, that's this, that's the epicenter, they're done. But then, like, it's incredible how much detail there really is. Like, you can keep zooming out, and it's like, okay, well, everybody in this circle was immediately gone, but in this circle their eardrums were ruptured, and in this circle their skin was liquefied from, like, it's horrifying stuff. Like,
right.
The takeaway is asteroid bad, and if we can do anything to prevent one of these asteroids from hitting us, that would be great. I think the most depressing part, though, at the end is, after you put all your little, I don't know where all these figures come from. I almost hope they're made up, but at the end it'll say, like, the likelihood of this happening. So, like, the first one I put in destroyed the whole eastern seaboard, and it was like, well, don't worry, that's only like 1 in every million or whatever. And then I did one that was much more reasonable, and it was like, well, that's like 1 in every 2,000 years. And I was like, well, wait a minute. It's been 2,000 years already. So we're due for this. Like, I don't like this story at all.
Yeah, I just flattened Bowling Green, Kentucky with one that's going to hit every 137,000 years. I mean,
yeah. I'm cool with those numbers.
That's no good.
Once they get smaller.
Yeah.
It's, and then, of course, Al at the end talks about, aptly, the efforts to just deflect asteroids, because it's kind of a big deal. But, this is something, if you have a morbid curiosity about this guy, and I think everybody does, right? You wonder, like, what would happen. Yeah. I also thought it was pretty cool that it really goes detailed. You could even select what the asteroid is made out of. Like, right. I think you're beat no matter what. But, like, you could do stone or gold or iron, and I didn't experiment around with it enough to know, like, what the composition does to you. But it's probably nothing good. It's probably just all bad.
Yeah.
Just levels of bad.
You certainly don't want it. No, it's interesting to think about how these kind of horrible disasters could happen. And, this is why you want to keep track of all asteroids of a certain size that could possibly hit the Earth, and maybe think about diverting them if it's at all possible. Didn't we just have a mission? I mean, what was the name of that one?
Dart.
Yeah.
You think that'd be easy to remember, right? Dart. Like
We need the link for Dart in here, because that was this experiment to shove on an asteroid and see if you could get it out of the way. Yeah, once every 100,000 years. It's not going to happen in my lifetime, but still, it's it'd be nice to not have it happen at all.
And even tiny asteroids, really. The couple times you had the one over Russia not that long ago.
Yeah.
I'm gonna make up a number now. I think it was only like 60 foot across or something like not huge. Blew windows out and did all kinds of damage. It doesn't take much.
All right, I'm gonna drop a small one. Let's see what I get with like a 60-footer, 20-meter asteroid. Yeah, and again, I'm gonna target Bowling Green, Kentucky. Nothing personal, y'all. I'm from Nashville though, and I can't put it on Nashville. You're the closest nearby. Result, airburst. Your asteroid blew up 7 miles above the ground. Ha! That's weak. An impact of this size happens once every 111 years. Oof. Still 2,000 foot wide fireball is pretty hardcore. And actually, it's close enough to the ground that some people actually did die from it. Some trees caught on fire. But significantly smaller damage than with that 1,500 ton one that I just dropped previously.
So proof I need to get out of the house more often. It was a 66-foot asteroid.
Ouch.
I was like, well, I'll spitball it. It was 60. I was pretty close.
That's pretty solid. Yeah.
Yeah. But it still did 33 million in damage.
Yeah.
So, yeah, not great. And 1,400 injuries. So, and that was something tiny. So, yeah. And to really add insult to injury, like, we're never going to detect that either. Like, it's so small. Something that size, even if you could detect it, you're not going to launch anything to intercept something that, like, you know what I mean?
Oh, I don't know. Actually, I wonder. I mean, what are the sizes that we can see? Oh, dude, one of this size hits every 66 years. This is getting terrifying now. I'm going to stop launching asteroids.
Turn it off.
This is miserable. I mean, it's a darn good thing that most of the Earth is covered by water, right? So, already you've got a 70% chance it hits in the water.
So this is interesting. They don't even consider it a potentially hazardous object unless it's 140 meters or bigger. Yeah, something that's 20 meters is like literally not even on their literal and figurative radar. Like that's just
right.
That's just like cost of being a planet. So when they say a hazardous thing, it has to be like way bigger than that.
I'm putting this one in the show notes. This was an article that Lewin wrote up last year about the DART mission, and then it was before we got to see it actually happen and run into the asteroid at full speed. But this one is the write-up of it just because it has phenomenal art. This is one of those ones where you should just go read the article for the Joe Kim art. Come for the nerdery, stay for the art. In the comments, Tony VR. The museum at Meteor Crater in Arizona had a simulation that let you vary mass, speed, angle of incidence. My young son loved it. After playing with it for a while, he managed to destroy the entire planet. This is still one of his fondest memories.
Yeah, right? Hey, Dad, remember that time? Remember that time I caused an extinction event?
Kids are monsters. My first quick hack this week comes from StyroPyro, and it's the world's brightest laser pointer. This is an incredibly funny looking gimmick. He was given a 24-element direct diode green laser array, and that alone is super darn cool. Direct green lasers haven't been available for much more than 10 years, and certainly in this kind of 1.5 watt power. Each one of these diodes is the coolest thing I've ever seen, and he's got 24 of them together in a big old steel tube looking like a laser pointer. It's driven by a 555 and a transformer, puts out 30 watts. It's a fun video. This is definitely not a make-it-yourself-at-home one. You can't even get the parts, but boy, if you could. Next up, Sergey Lyubka, Epic Guide to Bare Metal STM32 Programming, and that sums it up. He starts out here avoiding all of the tools that you are given to program an STM32 chip and kind of derives how the macros work, how the linker function works, everything, and builds it up from absolutely the bottom up. If you want a deep understanding of how these chips work and how they interface with the C programming language, this one is for you. And last up, Silicon Slapping Servos Solve Simon Says. Michael Schubart took a Simon Air game, you know, the ones that go beep, boop, beep, and then you go beep, boop, beep, and wanted to see how many correct responses it took to win at the game, but couldn't ever get past 20 himself. So he built a robot to do it. It's got light-dependent resistors that tell which of the 4 bits light up, and then it's got little silicone hands on servo motors that slap them. It's lovely, and it turns out 100 is the answer. You win when you get to 100 in a row. Good luck with that.
So my first quick hack is the Palm Pilot returns, this time in your browser. The Palm Pilot is kind of personal to me. It might not come as a huge surprise to listeners of the Hackaday podcast, but I did not have much of a social life in high school, but I did have a Palm Pilot, and it almost made up for it because I could play games and I could do stuff in my hand, and the other children with their pagers and stuff just looked on at me longingly. It comes from the Internet Archive, and it's really cool. I mean, it took a virtualized Palm Pilot and a huge collection of games and apps and stuff, and you can play with it right in your browser. A lot of it doesn't make a whole lot of sense in the virtual environment. Stuff like serial terminals and like infrared blasters that obviously don't do anything. And I can tell you from experience that none of the games that were available for the Palm Pilot are worth spending a lot of time on in 2022. But it is really cool that we can kind of capture this era of computing and put it out there in a way that others can experience it for the future. And people who would never even see a Palm Pilot can now go on there and see what things were like back in the graffiti days. Next up is hacker boards making finding the right single board computer easy. Now, this is something that has become even more important now that the Raspberry Pi has become difficult to find. This is an online database where you can browse a huge collection of single board computers. You can see what their specs are. You can see if they're discontinued. You can see what their, what the going rate is. It's a kind of a labor of love. We've actually covered how they take the pictures in another article, which is linked to this one. So they have like really like high quality, nice images of them, and it's a really great resource. If you can't find a Raspberry Pi and you're desperate for something else for your next project. And lastly, we have Merry Christmas, Rip and Tear. This is another project from the legendary Sprite TM, where he's created a teeny tiny little computer Christmas ornament that hangs from your tree, and it has a little tiny screen that's playing Doom. But it's not just playing like a pre-rendered, animation or anything. It actually is playing Doom, and if you hook up a Bluetooth controller to it, you too can play a teeny tiny, almost impossible to see version of the 93 shooter. Some interesting details in here. The ornament is powered by an ESP32 that Sprite had already ported Doom to, but in the end, it seems like he used the Game Boy Advance version through an emulator because it ran better. Hey, whatever gets you there, right? I would be more than happy to wake up to a little tiny Doom machine under the tree this year, in case anyone is listening and wondering what to get me.
All right, that brings us to our can't miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. And I picked Jenny lists. Perhaps it's time to talk about all those fakes and clones. This takes off from her buying a cheap spectrum analyzer clone. The SDR in question is a clone of the SDR Play RSP1. Of course, the hardware is not made quite up to spec and all of that. But what really rubs her the wrong way is that the manufacturers of this cheap device apparently want you to steal someone else's firmware and use it. And that raises ethical questions in Jenny's mind, and I'm down with that. She brings up along the way another spectrum analyzer, actually, from a German hacker whose call sign is DL4JAL. And he made this piece with free firmware, but not open firmware. And then when they started making cheap clones of the hardware, again, using his free firmware, he kind of got overwhelmed with support problems and pulled it off the market. And so this is kind of the two problems here. One, the SDR Play people put a lot of work into their firmware, and then they didn't release the firmware as open source, and they certainly didn't release the SDR as open source hardware either. But it's easy enough to reverse engineer that someone could do that. And I think, I'm not a lawyer, but the reverse engineering of that device and the making of a similar work-alike device, as long as you're not like stealing their copyright and they don't have a design patent on it, that part's actually legal. Where it gets sketchy is where they're like, you should then steal their software and use it on there. And Jenny reaches out to the SDR Play people and they say, yeah, this is really lousy. They do not like the situation at all. They can't do anything about it. And if they raised a hubbub about it, they feel like they'd only be giving the bad actors more publicity. And so they kind of didn't want to do that either. And I understand their feeling there. So in the end, Jenny's like, it's awesome to get cheap stuff, but if the projects in question aren't open source and you're kind of stealing from them, well, you're kind of stealing from them, and you shouldn't do that at all. The thing that strikes me as weird about the German spectrum analyzer was that he was giving the software away for free, but wasn't open sourcing it. And so then when the machine got cloned, it was like he got this huge support burden. And it strikes me, as long as he's not making money from the software or from selling the hardware, he kind of might as well just open up the source code and let the community handle the maintenance burden for him. I suppose that's like the secret advantage of doing open source firmware, open source hardware as a combo, is that if that's the case, A, you get someone to make a clone of it and sell the thing cheap so that lots of people get the thing. And B, you get some help on the firmware maintenance side too, hopefully from the community who finds it useful. Anyway, at the end of the day, Jenny discovers that there's also an open source software that will work with this horrible cheap SDR that she bought. So libmiri SDR works with it, and that's the way she runs it. She runs it just enough to determine that it's kind of a bad SDR in the first place and not worth her time after all. Probably should have just bought the real deal, given that the SDR Play ones are like only $100 anyway.
I'm gonna go the full Stallman on you here.
Do it.
I'm not gonna eat anything off my shoe, but I'm gonna say that I don't care. Like I don't feel bad for these. I don't feel bad for these companies because they're already making their money on the real hardware. And this is something that we see so much of in the open source space, but nobody seems to cry about it. I mean, how many of us have those little $10 logic analyzers and are using that with, Pulse View or whatever the open sort of thing is?
SIGROC and Pulse View. Absolutely.
Even if you want to look at 3D printers, you can buy your little cheap 3D printer and then you're going to go home and you're going to use Cura, which is Ultimaker Slicer, or you're going to use Prusa Slicer, which is Prusa Slicer, but they're open source, so nobody's too upset about it. So it's hard for me to feel any kind of, when they're selling the hardware and they're making their money on it there. I don't know why, why keep the software closed in the first place? So, at this point, if you're making the money on the hardware, and obviously the hardware is easily cloned, but I guess they have their own little secret sauce they want to try to protect. But I just, and I suppose that makes me sound kind of like a radical, but I just don't have a lot of, I don't have a lot of sympathy for them, when they're already making plenty of money and they have a clear revenue stream, whereas these open source projects have to, just hope for the best.
I also vote with my money, and whereas Jenny's like, you should pay up for the closed source software, I'm like, you shouldn't buy it in the first place. You shouldn't steal it either.
Yeah.
But just
No,
avoid it.
right.
Avoid it. Period. Use something if playing around with the software is important to you. If doing it cheap is important to you, don't use the proprietary software.
Yeah, I would definitely not recommend anybody buy something that they're then told to like pirate some software against the license or whatever. But I would just go back to the logic analyzers. I think you can use the real commercial software with them, but it never even occurred to me. You know, there was already a good open source software for it. You know, so just do that.
Yeah,
exactly. There's no reason to. It's kind of comical to me that people are still pirating software in 2022, and there's so many open source options
there's
out there.
so much good software.
I've always,
out there.
I've always felt that way, and people like, trying to, bootleg Photoshop just so they can, retouch some family photos. Just get GIMP. Like there's so many
good
options out there, and maybe it's just a matter of people, get name recognition and that kind of thing, but. But no, I mean, I get where she's coming from, and I certainly wouldn't feel comfortable with the situation either if I bought some hardware and they're like, hey, by the way, wink, wink, go over here and use this other person's software. So I think in that regard, it's it's a good service to point this out. And plus, it sounds like the thing doesn't work very well.
Yeah,
anyway,
it sounds like you just don't want this device.
I guess just don't buy this.
But like you say, we don't live in that world anymore. Like, we now live in the world of open software and open hardware designs. And if you can buy all those, then you don't have to make any of these horrible compromises. You get to have your cake and eat it too.
Well, my can't miss article comes from Al Williams again this week. He's on a roll. It is perfect, just in time for Christmas. It says, gift idea from 1969, a kitchen computer. Now, there were no home computers in 1969. We're still, 5 years away from the Altair, and the Altair was hardly hardly the home computer you would imagine today anyway. So, what is this about? How could this be a real thing? So Al explains that Neiman Marcus, which was for the anyone who's too young listening, that was a catalog where you would order things from. It's like Amazon, but they printed it on paper. So you would order these things, and it would come, and it would take 4 to 6 weeks, if you can believe it. One of the things that Neiman Marcus did is they apparently did these gag gifts every year, where they were a real thing, but they were so expensive, nobody probably would buy them, and most of the time, they sold one or two. Al says they sold a whole ship one time with sales and everything. In 1969, they offered a kitchen computer, which looks phenomenal. I gotta say,
Yeah.
It looks exactly like something that would be in 2001 Space Odyssey. The look is gorgeous, and I at first was a little confused by the dimensions of the thing, and then Al explains that front duck bill. You really have to look at this one. You're gonna have to look at the pictures. Is a cutting board. So imagine there is a integrated cutting board in your computer that weighs 100 pounds and comes up to your waist. And it was for sale for, what is this? Oh, $10,000
$1969
in 1969, which is closer to $90,000 today. It was based on the Honeywell 316, which was a computer that was actually out and being used in industry, but they just made this newer look. And there seems to be some debate about what exactly you did with it, because spoiler, no one bought it,
Right?
And apparently there's only one that exists, and it's in the Computer History Museum, and there's no display in the traditional sense. There's just a row of LEDs, or maybe even light bulbs, I guess, at that point, and the front panel buttons. So it's not super clear what it was to do. It probably was some kind of recipe thing, but only if you could read recipes in binary getting flashed across the lights, which is probably also why it came with a 2-week training class, because you're going to have to figure out how to operate this behemoth. And it's an interesting reminder, I think. It's a cool story and it looks awesome, and I wish I had one. But I think more than that, it's just a reminder of a time where they knew computers would be in the home, but they didn't know exactly how and what they would do there. So there was these early years where they were trying to be I guess it could be a cutting board, and then it'll blink recipes, and somebody was like, yeah, sure, roll with it, enough that they at least built one of them. And, you can imagine in an alternate reality where, like, we just never figured it out. and computers remained the domain of, universities and laboratories and stuff because people were so sick of trying to read a souffle recipe off a blinking light bulb.
I mean, this is a 1969 computer, and you toggle the data in using 5 different sets of 3 buttons. Each one of them lets you put in an octal digit. And so, like, in principle, you're like, what? I need to know how to make shepherd's pie. And so you type in the octal for shepherd's pie.
Yeah, really. It does not.
And it blinks back to you the octal for go get a quarter pound of steak. I mean, like, I can't even.
It's absolutely preposterous, even for us.
It's absolutely preposterous. But yet, the like home computer doing your kitchen recipes was like this trope / dream / whatever. It was going to be the killer app for bringing computers into the home for like a long time. And I have no idea why. From today's perspective, it seems just so implausible. But yeah, I do love that, like, Joe Kim totally hit it out of the park with his art on this one because it is this kind of Jetsons view of the future where, like, the computer tells you how to make the food or makes the food for you.
It's no surprise, right? It's Joe. But man, did he kill it. Like, I was looking at it for so long. Like, is this a real Jetsons? Like, is this did they do a tie-in episode?
But how did they have exactly that computer?
Yeah, right? Well, it was the Neiman Marcus tie-in and try to get you to buy the thing.
Yeah.
No, I mean, I could almost see, I guess if they had added a printer, I would even allow for, like, a cookbook that had the binary codes, and then you could toggle it in, so that you could put way more, you just like imagine a spreadsheet that says like souffle on the left and then like a 16-bit binary sequence, and then it printed it out. Like, that would have been actually huge, I would think.
There's a teletype machine somewhere around the corner, and you just like you type into
what do you
this
want
thing
for $100,000 though?
It's somewhere around the corner. It spits that out. I don't know, man.
But no, I mean, I think that probably would have elevated this into like a practical thing. I mean, it's interesting to think that maybe they were just that far off. Like, if they had just thought to add like some kind of printed thing that a normal human can interact with, they might have got a jump on the whole computer industry a decade before it started. Otherwise,
I am looking at the ad for this right now. That price includes a 2-week programming course.
And then an apron too. I think it said too, right? The least you could do. We should say too, the recipes are all stored on core memory because why not? And they got this, this woman who's so pleased to have a computer in her kitchen that seems to take up all available space. Like, you can't open the refrigerator because the back of this thing is literally against the refrigerator. If those are the ovens on the right, she's not gonna be able to open them. So after the photo shoot, she's just like, well, thanks a lot. Thanks a lot. You've ruined my kitchen. Take it away from me. $100,000 down the drain.
Well, that about wraps it up for this week's Hackaday Podcast. Thanks very much for listening. So go check out the links and continue the discussion over at hackaday.com/podcast. If you see anything cool or do anything cool, shoot us a tip. tips@hackaday.com. And until next week,
keep on hacking. Mechanical Nightmare. Okay, at least.
Yeah, Mechanical Nightmare.
Internet celebrity.
Excuse me, fancy YouTuber. Things that won't make the final cut.
Get that titanium dioxide in them. Titanium poisoning.
Sniffing the white. Yeah, but there's no sense in buying closed source anything anymore. Hooray, we've won.
Well, I must be on Hackaday. And don't let us find out you're listening to this with a closed source player. the little meme with that little puppet who's like side glancing. Like they're listening to the podcast on their iPhone with their closed source player. Like, they're coming for us.